So we have the same instructions here. This is part 2. Tune in for part 2 next time on Dragon. Okay. So on this one, it says with same instructions. It says to count the number of outcomes, the total possibilities, the total possible situations. So in this situation, a spinner can land on red or blue. You spin 4 times, and then you roll a 6-sided die. So now we're gonna try and figure out. Okay, so what is the outcome? What would an outcome look like? Well, I could. Okay, first of all, what's a spinner? Like when you play Twister, there's like a little circle with an arrow on it. Like there's a little hole in the middle, and then this like an arrow. It looks like a clock, and you flick this, and it's like pew, and then this spins around, and it lands on either like the red side or like on a red color. This is saying red or blue. It doesn't have to be 50-50, but I'm just gonna make it 50-50. So like it's a way to choose randomly, like in Twister, you spin it and it chooses randomly. And then maybe we're playing a board game, so we do a spinner and then we roll a 6-sided die. So, what could an outcome look like? Well, we have to spin 4 times, so that means I have 4 red or blues. So maybe the first time I get red, second time I get blue, third time I get red, next time I get blue, and I roll a 3. Or something. So I got 1, 2, 3, 4, 5 spaces to fill. This is, I think, how you should go about using that shortcut each time. Because then I can say, all right, 1, 2, 3, 4, 5. How many options do I have here? Well, 2. And I have 2 options here, and 2 options there, and 2 options there, because it's red or blue. Do you understand? Maybe you got to pause. You got to think about it in your brain. You got to think with your mind box. And then at the very end, it's a 6-sided die, so that means I have 6 options. So there we go. That's what we get there. Do you understand? Do you understand it? So the total here is going to be 2 times 2 times 2. Times 2 is 16. Times 6 is 78. I don't know. It's 96. It's 96 here. So this equals 96 if we multiply them all together. Now let's try and think of a tree diagram. So what could happen? Well, for the first space we could have 2 options. So say we have red and then we have blue. But then I could also have red and blue for the next space. Red and blue for the next space, but I could have a next one that's red and blue. I'm figuring how to do these trees, red and blue, right? Or because I have 1, 2, 3, 4 tiers, and then the last one has 6. So like I'm not gonna do this. This is too much. And then so like I'm saying in one option, if I have all these reds, and I could still have 1, 2, 3, 4, 5, 6. Rolls of the dice. 1, 2, 3, 4, 5, 6. Sorry, die. And then it's just too much to do. I'm not going to do a tree diagram. I'm just going to use the shortcut. It's much better. It takes way less writing, way less thinking. The first step, though, is to write out one single outcome. And then you can choose, okay, how many choices do I have for that first thing? Well, I could be red or blue. That's 2 choices. I can count the 2. Like 0, 2. Oh, well, shoot, I screwed it up. No, I'm kidding. It's 1, 2. If you're counting normally, if you're a computer science person, you can count from 0. You start from 0, but that's not the matter. Okay, so that's that problem. Let's do another one, huh? All right, so let's look at this one. We got a jewelry store, and they sells gold and platinum and rings. They're selling rings, okay? We selling rings here. We selling rings there. We sell rings everywhere. It's a jewelry store. Each ring is available in 8 styles. And is fitted with 1 of 10 gemstones. So I'm thinking here, well, I got, what's one single outcome? That's my first step. Always the first step, look at what is one outcome. Well, I have either a gold or a platinum ring, so that's the first choice. And then each ring was 8 styles, so I pick style. So 1 single ring, gold or platinum. 1 single style out of the 8. And then 1 of the 10 gemstones. Okay, and then How many choices do I got? Well, I got 2 times 8 times 10. And that's just 160. So that's it. That's how easy this is. That's how easy it is, and that's what it's gonna be. Now we could make a tree diagram, but it's gonna be too much. I'm not gonna do that. All right. So get out of here. All right. Get out of here with that. Let's take a look at example 4. How many 6-digit numbers can you make with the numbers 4, 5, and 6? What? Okay. Repeats are allowed. What does that mean? Well, let's make an outcome. What is one single outcome? Well, it's a 6-digit number. So that would mean I have like 4, 4, 5, 6, 5, 6. That's one number. I have 1, 2, 3, 4, 5, 6 digits. Well, whoops, that's the next problem. 1, 2, 3, 4, 5, 6. I have 3 options here. 3 options here. 3, 3, 3, 3. And so I just multiply them all together. It's crazy. Repeats are allowed, meaning I could have like 4, 4, 4, 4, 4, 4, 4. So I still have 3 options the whole time. And that's going to be 729 of those numbers. I could have 729 6-digit numbers made out of the numbers for 4, 5, and 6. All right, now let's extend it. How many 3-digit numbers can you make with the numbers 1, 2, 3, 4, or 5 if no repeats are allowed? What? Well, first of all, one of the outcomes would be 3 spots. It's a 3-digit number, okay? And I'm choosing, okay, so for this digit, how many choices do I have? Well, I got 5 choices. I got 5 choices. But no repeats are allowed. No repeats. What does that mean? It means if I chose one here, I can only have 2, 3, 4, or 5 in this spot. But I don't know what I chose, and it actually doesn't matter. All I just care about is one of them is gone. I have 4 left. Like, it doesn't matter which one is gone. I still have 4 left. So how many choices do I have for the second spot? I have 4 choices. Oh, that's different than what we've done before. But it's kind of satisfying, no? No one's here. Who am I talking to? Okay. And then the last one, well, I've chosen 2. I don't care which 2. I just know that I have 3 choices left. So this would be a 3. So actually, the total number, without repeating, is 5 times 4 times 3, which is 20 to 60. 60 numbers. I can make 63-digit numbers, and none of them will be 2, 1, 2, or something like that, where I have digits repeating. So there we go. That's it. We're done. Goodbye.